Hello everyone, my name is AMMAJI DUPPADA, and today in this session we are going to see non-exact differential equations. In that form, how to solve a particular non-exact differential form equations like. So far we have seen, actually even under the method 7 we have seen exact differential equation form. Exact equation they have given in the question is looking like same even in the two cases, whether it is exact or non-exact. So m dx plus n dy is equal to 0. M and n are the functions of x comma y. You know, if it is exact means, you know the condition. In order to be an exact differential equation, we know that dou m over dou y, you have to calculate, dou n over dou x, you have to calculate. If both are equal, then it is automatically called, it is an exact differential equation. If it is an exact differential equation, you know the direct solution. Integration of m dx, m means function of xy, integration of n dy is equal to constant. Here you have to treat y is equal to constant. Here you have to remove all x terms. It means free from x terms. N should be free from x terms. It means you can keep x is equal to 0 in this case. So like that it is. So this is the direct condition, direct solution if the equation is exact. If the equation is non-exact, then what are the cases are available? Generally, if the equation become non-exact, it means if dou m over y is not equal to dou n over dou x, then it is non-exact. I can say the condition is they should not be equal. So, okay, it is non-exact. Now I understand it is non-exact. It means I cannot apply this solution. Like I cannot apply this solution. What I have to do now, if it is a non-exact differential equation, I have two possibilities. Like again, it means there are two particular ways to follow the problem to solve. One way is I treat this one as method 8 because already so far we have seen 7 methods. So this is under method 8 I will consider. So this one case 1, let us say, in this case 1 non-exact differential equation, dou m over dou y is not equal to dou n by dou x, so it is non-exact. Under that case 1 is method 8. What we do is, in this we do inspection method. Method 8 is called inspection method. Under case 2, again there are different methods actually. Under case 2 there are different methods. It means if you are unable to solve the given non-exact differential equation by inspection method, then you have to go for case 2. In the case 2, again there are different methods. So that methods we will be giving name after that. There are different methods, we will see later on that one. First we will see given equation is not exact. If it is exact, we know that already under method 7 we have done. If it is a non-exact differential equation, then I have to check two cases. Like in that case 1 is inspection method, in the case 2 is there are other methods are there that we will be seeing later. So in the inspection method, what is the meaning of general inspection? Inspection means I will check it. Actually I simply go through the problem very letter by letter. I will check the problem. I will check it. It can be solved easily. Whether it can be solved easily. That is what actually I inspect. Easily means what method it is like. It is almost like variable separable method only. It is almost like a variable separable method only. So what are the, how we do inspection? What are the formulas I need to do inspection? What are the basic equations I need to know to do the inspection? That we will see first. So now what we are going to see is inspection method we are seeing. So that one method 8 we have seen. Method 8 we have given name method 8. Under which case it is? non-exact. In the non-exact, given equation is non-exact, in that inspection method we are seeing. Inspection method. So what are the formulas are required? Generally, actually we group in this inspection method. What we do is, once the problem is given, we group some terms into one group, we group another terms into another group. Once two groups came, the two groups I separate, like variable separable method I said. We separate the two groups and we will get solution simply. So that is the simple thing here is, what we do is here, we regroup the given question. We regroup the given question into two groups. Once if you get the two groups, automatically you will integrate. You will apply integration like variable separable method only. So in order to regroup the terms, you should know some formulas. That formulas are some basic formulae that are needed. They are dxy. You know that actually. This is very simple. UV formula. X dy plus y dx. You know, dy over x. X dy minus y dx over x square. If it is dx over y, you know that actually. That no need to write again, but I am writing so that it will be easy. Y dx minus x dy over y square. Dy over x, dx over y. It means why this regroup I said is, when the question have this term, when the question have x dy plus y dx term, then what you can do? You can regroup into dxy, so that the problem, solving the problem is easy. First of all, the question having this term, then automatically you can replace or you can regroup into dy over x. If the question have this term, you can regroup into dx over y, so that the solution is easy. Like that, there are other formulas like x dy d log x over y. This formula is x dy minus y dx over xy. It means if the question have these terms, right hand side, automatically you can replace with this left hand side, log differentiation of log x over y. You can regroup into this. And there are other formulas. Differentiation of tan inverse y by x. Differentiation of tan inverse y by x is x dy minus y dx over x square plus y square. It means if the question have this term, automatically you can replace with this term. It means you can regroup into this. There are other formulas I am writing. Differentiation of half log x plus y over x minus y. This you can write x dy minus y dx over x squared minus y squared. These are the basic formulae that are more than enough to do inspection method. But one thing you have to understand here, how this formula came. It means you may think like, this is differentiation of UV formula dx over y. You know that it is very simple. X dy plus y dx. Differentiation of y over x. This is also a direct formula. You know that actually. You can remember this one. Differentiation of x over y, you can remember. Differentiation of log x over y. You can derive this also if you do not know how to remember this thing. Let us say this portion, we can see the differentiation of log x over y. This we will solve separately. I will solve so that you can understand how this formula to remember like. differentiation of log x over y. Now I am going to solve. Because we have seen direct formula, I have written, but now we are solving differentiation of log x over y. See, differentiation of log x is what? 1 by x. So log of something, 1 by something. That something you have to differentiate. It means differentiation of x by y. What is differentiation of x by y? Y dx minus x dy by y square. This x by y you take top. It means it will be reverse, y by x into y dx minus x dy over y square. Y will cancel. It means y dx minus x dy over x into y. 1 y will cancel here. So automatically this formula came. It means differentiation of log x over y is it right? Differentiation of log x is 1 by x. So 1 by x over y. So differentiation of x by y you have to do. It means y dx minus u by v formula. Y dx minus x dy divided by y square. Yeah, exactly. So y dx minus x dy over xy. This is the formula for differentiation of log x over y. So it means you no need to remember any formula, like you can derive also. Like the same manner, you can derive differentiation of tan inverse y by x also. You can derive if you know differentiation of tan inverse something. 1 by 1 plus something square. It means 1 by 1 plus y by x whole square. What is x you treated y by x? Differentiation of tan inverse x, y by x, right? So you have to differentiate this term again. So what is the x dy minus x dy minus y dx divided by x square. It means finally what you will get is x dy minus y dx over x square will be cancelled. X square plus y square term will remain. That's it. It's very simple. You no need to remember actually by heart. I mean, you no need to by heart any formulas like, but you can derive it. But you should know what you should know, that is, if this term comes actually in the question, if this term comes in the question, you should know you have to regroup with the d tan inverse y over x, so that solving that problem is easy. So that is the only importancy to remember these formulae. You can remember or you can derive, but to do inspection method, if the given equation is non-exact form, it means dou m over dou y is not equal to dou n over dou x. You have two ways. One is inspection method. Another case is there. That case we will see later on. So now we will solve one problem. So solve y into 2xy plus e power x into dx is equal to e power x into dy. See, firstly, it is looking like mdx plus ndy is equal to 0. You know this, how it is like, this term if you treat as n, y into 2xy plus e power x dx, if you bring this side, minus e power x dy is equal to 0. It is m, it is n. So mdx plus ndy is equal to 0. It is looking like that. Now, firstly, you have to check whether it is exact or not. Right? If it is exact, there is a solution like direct solution. So find dou m over dou y. Dou m over dou y you find. You find dou n over dou x. What is n value? Minus e to the power x. What is m value? This thing, you know that. M is equal to, I am multiplying 2xy squared plus e power x into y. Now, dou m over dou y, first term. 2x constant, y square differentiation is 2y. It means 4xy plus dou m over dou y. With respect to y you are doing. So e power x constant. Dou by dou y over y is 1. It means second term you will get e power x. It means dou m over dou y, this I got. Dou n over dou x, what you will get? Minus constant, e power x is e power x only. It means dou m over dou y is not equal to dou n over dou x. So it is non-exact. I can say it is non-exact. Now what I do first, I will check whether this problem can be solved by using inspection method or not. That I have to see first. So what I do is I take again I will write the same equation once again. Y into 2xy plus e to the power x into dx is equal to e to the power x into dy. This is the equation. So what I do is I just bring this. So now I'm inspecting. Now see, I'm inspection I'm doing, like it means I'm just checking whether I can solve it or whether I can regroup this equation into different form. Like, see, by seeing this e power x into dx, e power x into dy, in this e power x into dx term is there, in this e power x into dy term is there. It means there is a possibility something like I can group it. There is a possibility to regroup the equation into different form. So that idea we should get it. How should we get this idea? Y into e power x into dx term is there. Here e power x into dy term is there. It means uv formula or u by v formula, there is a possibility. So with that possibility, I am checking like, so I am multiplying with y, 2xy squared plus y into e power x dx. Here also dx, here also dx, minus e to the power x dy is equal to 0. The equation is now looking like this. Now what I do is there any possibility to solve? Now we will see. So if you divide with y square, let us say I'm dividing with the y square. So divide with y square. So 2x y square into dx, it means 2x into dx only you will get, plus y into e power x dx by y square. It means e power x into dx over y you will get. Is it right? I'm y into e power x, I'm dividing with y square exactly. So second term, e power x into dy divided by y square is equal to 0, right? So now what I do is, here I am multiplying with y, automatically here y square will come. It means y square term is common, like, you know, in the two parts, like denominator part it is common. So now you see 2x dx plus y e power x dx minus e power x dy over y square. See, it is looking something like, you know, I can regroup into this equation into another form. Like, what is that form? See, it is looking like u by v, v into du by dx minus u into dv by dx by v square. It means this is differentiation of e to the power x over y, u by v formula, y into e to the power x dx minus e power x into dy divided by y square. See, exact thing is there here. It means this second part I can regroup into 2x dx plus differentiation of e to the power x over y is equal to 0. See, now the equation I got like it is simple. 2x dx 2x dx plus differentiation of e to the power x over y is equal to 0. Now see, it is like almost variable separables. It means two variables are something like there, dx and dx is one type of term, d into e power x over y is another type of term. You can apply integrator directly. Apply integration, because differentiation terms will go away. Integration of 2x dx plus integration of differentiation of e to the power x over y is equal to 0. It means you will get a constant, right? Something like automatically you will finally you will get a constant. So is equal to some constant you will get. So 2 into integration of x into dx. What is the formula? X square over 2. Differentiation integration, both will be cancelled each other. What term will remain? E to the power x over y is equal to some constant. Some constant. So 2 will cancel. So what you will get finally? X square plus e to the power x over y is equal to constant. That's it. Your final solution having x and y terms only, because x and y terms only they have given in the question. This is the way you have to do inspection. It means, like, how you can regroup. Only one thing you have to you have to remember: when the question is non-exact form. If the question is non-exact form, it means dou m over dou y is not equal to dou n over dou x. You have to check whether I can solve the problem by using inspection method or not. You have to check. So this is the right. So this is the problem they have given. I check dou m, dou y, dou n over dou x, non-exact. If it is non-exact, then you have to go for whether you can solve by using inspection method or not. If you are able to regroup into equation into a simple form, then you can simply see this is the form. Actually, I made it. I regrouped. I used this formula. This formula I have used to regroup my this equation. So this is the way you have to solve the non-exact differential equation form. But by this time, you should get one doubt. That same question I am writing once again. So the question is this, right? Y into 2xy plus e to the power x into dx is equal to e to the power x into dy. This is the question. Now we have seen many methods, right? This is the problem I have to solve. It is looking like mdx plus ndy is equal to 0. That is very simple, because you can see that it is looking like mdx plus ndy is equal to 0 form. But not only that form, right? Not only that form. See, first, when the question is given, they may ask, in the differential equation, why the many students cannot understand, I mean, they feel difficult to understand mathematics is, firstly, there are many methods actually. So far, we have seen eight methods with this, eight methods. In this, firstly, the student should get doubt that under which method it falls. The question, first you have to understand under which method it falls. Under which method it falls. So this thing first you should understand. So this question actually generally not only non-exact, by using another method also you can solve this problem. So firstly, by seeing this question, first method is what? You have to check whether I can do by using variable separable method or not. See, immediately you have to inspect all these things. You should not take much time to think about this. So if you try x and dx terms and y and dy terms, you cannot separate. So variable separable method, by using variable separable method, this problem you cannot solve. Next, second thing is, we know that actually there is a method called linear Leibniz form. Linear Leibniz form. So linear Leibniz form, you know that dy by dx plus py is equal to q. Whether is it available in that form or not? If it is available, you can use linear Leibniz form only. Also, third one, you can check whether it is available in Bernoulli's form. And then you know that whether it is homogeneous or not. If it is non-homogeneous or what? If it is non-homogeneous under case 1 or under case 2, which case it is? So firstly, I have checked the question, the given question, variable separable method, definitely not, I am sure. Linear Leibniz equation. What is the linear Leibniz equation form? dy by dx plus py is equal to q form. But p, q are functions of x. Actually, my problem is looking like that. Not exactly, but I think it is looking like linear Leibniz equation form. Let me check. So dx term that you side you take. dy over dx. It means from this question I am writing. dy over dx is equal to ex, you bring this side. It means 2x y square plus e to the power x into y over e to the power x. It means the equation is looking like dx by dy plus e power x cancel. Second term I am writing first. Sorry, dy by dx, okay, is equal to first term only I am writing 2x y square over e power x plus y. I am repeating once again. Dy by dx, this y I am bringing this side is equal to 2x y square over e to the power x. This way I can write the given question. See, it is almost like dy by dx plus py, p is equal to -1 here, is equal to q. It is almost looking like linear Leibniz form, but not. Why? P comma q are definitely should be functions of x. P is -1 only, so satisfied. What about q? 2x into y square over e power x. It means q terms, q having y terms. So this is not linear Leibniz equation form. What is Bernoulli's form then? Now you have to check whether it is Bernoulli's form or not. dy by dx plus py is equal to q into y to the power n. P comma q are functions of x only. So now this problem is satisfying Bernoulli's form. It means you can solve this problem by using Bernoulli's method also. You no need to solve by using only non-exact differential equation. So you have to solve by using inspection method only. No condition at all. But if the question is given, solve by using Bernoulli's form, solve by using Leibniz form, solve by using non-exact form. If the question is given like that with a condition, you have to solve in a particular method only. If the question has not given any particular method, you can use whatever the method you like. Why? Because this question is non-exact form, so you can solve by using inspection method, and it is in Bernoulli's form also. So why can't I do by using Bernoulli's form? You can happily do, no problem at all. But they should not mention you have to solve by using non-exact form only or by using inspection method only. If they ask by using inspection method, you have to solve by using inspection method only. But generally they don't ask. Generally they don't ask in the examination. So now we will solve the same problem by using Bernoulli's form. How to solve that? Like, so now we will solve this one by using Bernoulli's form. Okay. Can I complete? So now we solve the same question by using Bernoulli's form. So here I will take the same equation. Okay. The question is this, right? I repeat. Now the same question I am doing by using Bernoulli's form. Because the question is also having Bernoulli's form hiddenly. So what is the question? dy by dx minus y. question is dy over dx minus y is equal to 2x over ex into y square. This is actually Bernoulli's form. Same question actually. Same question I am taking. After little conversion, I got in Bernoulli's form. Like I'm little make it bigger. Okay. Now it is in Bernoulli's form. So how it is? How we are telling it is Bernoulli's form? Because dy over dx plus dy is equal to q into y to the power n form it is. T is minus 1, 2 is 2x over e power x, but y power n is y square. It means n is equal to 2. But in this case, so it is not linear form. So I have to convert Bernoulli's form into, you have to convert into linear Leibniz form or Leibniz form directly. LEB. Leibniz form. You have to convert. How to convert? We know that what is the process? Whatever the term is there, with the term you have to divide. So divide with the y square. It means y to the power minus 2 into dy over dx minus y by y square. It means y to the power minus 1 is equal to 2x over e power x. Now, this y to the power minus 1 you have to treat as z. Y to the power minus 1 you have to treat as z. In that case, both sides, if you do differentiation, minus 1 y to the power minus 2 into dy over dx is equal to dz over dx. So it means y to the power minus 2 into dy by dx is equal to minus dz by dx. It means this term I can replace with the minus dz over dx minus y to the power minus 1. What is the y to the power minus 1 value? You have treated as z. So z is equal to 2x over e to the power x. Now you see this equation is exactly looking like linear form. I converted into linear form. Dz over dx plus z is equal to minus 2x e to the power x. So dy by dx plus py is equal to q form now. So what is the small p here? 1. What is the small q? Minus 2x over e to the power x. Now, what is the formula? You know that the solution is z into e power integration of p into dx is equal to integration of q into e power integration of p into dx. Small p, these are, is equal to constant. So z means what? Z means y to the power minus 1. It means 1 over y. E power integration of p into dx. E power integration of 1 into dx. It means e power x only. Is equal to integration of q. What is the q? Minus 2x by e to the power x. What is the e power integration of p dx? E to the power x plus constant. E power x will be cancelled each other. So e to the power x over y. This integration of minus 2x. Minus 2 constant, x square over 2. 2 will cancel. So it means x square will remain. That x square you can bring this side. Plus x square is equal to some constant. That's it. It means now you see, same x square plus e to the power x over y is equal to constant is the solution we got even by using inspection method. This is the solution we got even in the case of inspection method. See what we get in inspection method, x square plus e to the power x y c. This is the solution we got by using inspection method. Same solution we got here also. Here also we got same solution. It means the method can be solved by various any problem can be solved by various methods. You have to check which method is easy unless they have given a particular method. So final point is here, if the question has given to solve by using a particular method, please follow that particular method only. If the question has not given to solve in any by using any particular method, then you can solve the method which you feel easy or which comes to your mind easily. So that you have to check. So with this this non-exact differential equation form is done. So I will show you from the beginning what we have covered today. Okay, first what we have done, so simple non-exact differential equation form we have taken. It is like mdx plus n dy is equal to 0 form only. What is the condition for non-exact? Dou m over dou y is not equal to dou n by dou x. If it is non-exact, there are the two possibilities or two cases. Under the case 1, method 8 we have taken directly what is called inspection method. Inspection method. By using this inspection method, we have solved one problem, but unfortunately, we come to know that that problem also can also be solved by using another form called Bernoulli's form. So we have tried that Bernoulli's form also. We got the same solution. It means some problems can be solved by using various methods, but solution should be same. If it is non-exact, under case 2, and you cannot solve by using inspection method also, in that case, what are the other possibilities and what are the other possible methods? In that case, we will solve in the coming session. Thank you all for watching this video.